Good morning. I'm Professor Colin Porteous from the Macintosh Environmental Architecture Research Unit, and I'm going to speak in this slot about a project that was completed 15 years ago, the East Hole Solar Demonstration Project, and indeed helped set the research unit MUU up at that time in the early 1990s, with the particular theme of how close it could get to zero carbon today. In order to make a start on the zero carbon theme, and of course the first thing is to try and define zero carbon. In Scotland, the Sullivan Report of 2007 defined levels of carbon emissions relative to the Scottish technical standards of that same year. So they had low carbon set at 30% of the 2007 standards, very low carbon at 60%, and finally they had total life zero carbon, which, as the name suggests, got to 100% relative to the technical standards, but also included embodied energy, just to make matters slightly more complicated. The regulated energy standards to which it was referring in the Scottish technical standards of that year relate to space heating, water heating, and lighting, and any fans, pumps, etc. associated with ventilation. So it's not the whole of the energy involved in the building, and indeed the total life zero carbon, which rather implies that everything is taken into account, takes into account effectively what the building uses rather than the people inside the building. So it excludes all the power use in terms of, say, washing machines, dishwashers, and so on. On the other hand, the UK-wide definition of zero carbon by Her Majesty's Revenue and Customs includes all that additional power use. So when they mean zero carbon, it's something quite different from the Sullivan Report. And the HMRC definition is in turn aligned with the Department of Communities and Local Government, applicable in England and Wales. And in each case, the requirement is essentially that all the generation renewably occurs on the site. The only softening of that position being to allow private wire arrangements. Just to put this into a European context, the HMRC and the Department of Communities and Local Government definitions seem to align relatively closely with the German Zero House definition of zero carbon. German Zero House is essentially passive house plus. Passive house required total primary energy consumption, including everything, all power use of no more than 120 kilowatt hours per square metre per annum. Zero House has lowered that to 100 kilowatt hours per metre squared per annum. So it's 20% more stringent, but the key thing about the Zero House as opposed to passive house is that it requires net zero carbon emissions over the year. So, having set the scene in relation to what we're talking about in zero carbon, the aim here is to look at what East Hall achieved and to see whether it could achieve zero carbon in terms of the Scottish standards, in terms of the Sullivan Report. In summary, the East Hall project achieved taking substandard 1960s housing stock out of fuel poverty, and in doing so it made use, of course, of upgrading insulation, upgrading heating, but it also made use of both passive and active solar heating techniques. If we go first of all to the condition of the houses beforehand, the construction looks traditional, traditional pitch tile roofs, traditional walls, but in fact the construction of the walls was non-traditional. And it was a special block called a Wilson block, and that particular Wilson block, which we can look at on this slide, comprised two very thin skins joined together in each block by 3 ties. The heat loss through this block was remarkably high, a U value of approximately 2.5 watts per metre squared K. Now one might compare that with a traditional masonry building of the beginning of the 20th century of about 1, so it was something like 2.5 times greater than a traditional masonry tenement. So fuel poverty was an acute issue, and the position adopted was to divide that rate of heat loss by 10. And so on the right hand side of this slide we can see the cavity itself filled with insulation, but over and above that there's external insulation on the outside of the wall. And the external insulation gets over the problem of any cold bridging that would still have occurred through the ties in each block. So looking at the whole picture, East Hall was derived from a competition, and this was a drawing by one of the participants of that competition, John Gilbert Architects. We can see that the house comprised a living room, main bedroom, smaller bedroom, bathroom, kitchen. The external walls were of course relatively easy to insulate in the manner shown, but there were special conditions. There was a wall to the stairway entrance. That was a cavity brick wall, and that was cavity insulated. There was a single skin of brick wall to a store which was unheated in this location, and that had to be internally insulated. So it wasn't just simply a matter of the insulated construction to the external wall. The insulation had to take account of very specific circumstances. And then the existing open balconies or verandas were an obvious target to glaze in and make into a glazed buffer space. And on the other side of the house, the opportunity was taken to expand the very small kitchen area into a utility space, which was again a glazed space. The issue, of course, with housing of this age is that the orientation is predetermined in all directions. So it might be that that particular veranda faced due west, or it might be it faced due east, or it might even face due north. It could, of course, face south. But having a glazed buffer space on each side of the building actually took account of all orientations in a reasonably satisfactory manner. Over and above insulation and the glazed spaces, which predominantly are helping in terms of, one could call it edge insulation, but the other way to look at it is looking at the ability to preheat air for ventilation. So the air coming into this bedroom, for example, is preheated in that space between the bedroom and the outside, and therefore cuts down on the ventilation loads. Similarly, air entering the kitchen, which will be fairly rapidly exhausted, but it's still, instead of taking air at ambient temperature, it's taking air at the temperature of the buffer space before it reaches the kitchen. And in the same way, air can be taken from the veranda space, the glazed veranda space, via a French window into the living space rather than through the direct window. Over and above all that, we see here the initial sketch ideas, not finally as built, but the initial sketch ideas for a solar air collector built into the roof and also a vertical air collector built into this wall. Well, what were the pitfalls of what was achieved here? If we were doing it today, the first thing we wouldn't do is do the space heating as was done then. That point in time, the tenants' prime concern was to have a full central heating system. Actually, because we were insulating to quite a high standard, we could probably have got away with a partial central heating system, but that simply wouldn't have been politically acceptable. The other thing was, again, at that point in time in the early 1990s, tenants still wanted to have a focus fire, and some of them already had gas fires in the central chimney stack. The logical thing seemed to address gas central heating, not with a modern condensing combi boiler, but at that time with a radiant fire with its own back boiler, and that served the existing hot water cylinder, which is located in a cupboard directly next to the chimney. The problem with that is A, the boiler has a very low efficiency compared with a modern condensing boiler, and B, it required a permanent air supply, effectively a hole in the wall. And so not only was the heating system less efficient than one could achieve today, the rate of ventilation was also a good deal higher than would be required if one had had a combi boiler, say, located either in this utility space or in the kitchen. So that was a significant weak link. The other weak link was the fact that we only use standard double glazing to the main window in the living room and also the small window in the small bedroom.